Good afternoon. As she points out, I'm Dave McAllister. I work for a company called Scalyr. Scalyr does log management, monitoring, alerting, metrics, tracing, all those different things. But I'm going to give you as short a sales pitch as I possibly can. That's pretty much it. What I'm here to talk about today is really about kind of what you need to think about when you move into an orchestrated environment. There are a lot of orchestration tools in the marketplace, but honestly, Kubernetes has kind of won the battle. So this is going to be a talk that covers a little bit about Kubernetes, a little bit about containers, and a whole lot about some painful rules that I've learned that hopefully you don't have to repeat. So back in the old days, which people like me remember, monitoring was a whole lot easier. First we had a server, then we had an application, and then we had a log. Monitoring in this case pretty much meant checking to see if the little light was on the server, so it was getting power, listening to the fans spin up or down, or waiting for the phone to ring to somebody to tell you that it was broken. That was pretty much what monitoring started as inside of that. Then things got interesting. All sorts of things came into being. Let's pick on microservices, one of the hot topics in the world today. The concept of microservices says, build a service small enough to deliver what's necessary, while at the same time increasing the need for messaging, data communication, and data streaming to make it more complex than you ever thought possible. Scale, IoT space. There's a European car company who plans to put 20 million connected cars on the road by 2020. That works out to, I think, roughly 8 zettabytes of data uploaded to the cloud every year. Just to give you an idea of how scale matters. I can, having worked in the IoT space, also guarantee that no matter what you think your IoT involvements look like, you're going to end up with more devices at every time. Scale grows and scale matters. If you're looking at tools, make sure the tool was built with scale in mind. Scale is not an add-on. Scale is something that happens while you're designing. But you can think of these things kind of as levels of extraction. So we've gotten more complex. We've added more layers to it. And the short version of that really comes down to is that extractions make our life simpler. Note that simpler is not easier. You still have all the components that are back there. There are still servers someplace. There's still networking in various places. The difference is you didn't build it, and you didn't maintain it, but it's still necessary for it to be running, for you to have your applications up and running at the same point in time. That means that abstractions make digging a lot harder. You no longer have control over what's running on, what's in the background, or how things are actually performing. And therefore, it's necessary for you to figure out ways of monitoring things that you don't control at the same point in time. So, while simpler can be a good thing, it means that we can develop faster and we can deliver faster. Unfortunately, we have this real bad tendency to take that savings in time and technology and decide to reinvest it in more cool stuff. We build better UI, we build APIs for mobile machines, we build personalization engines. In short, we seem to be kind of geared to a less than zero-sum game. So even though life got simpler, we tend to try to make it more complex at the same point in time. This design philosophy means that when something goes wrong, it's harder to tell something went wrong. And by the way, I'll tell you that the tools that monitor and manage and do these logs tend to be behind the cutting edge of development. They're not up front. They're not where the development starts out. They're actually behind the edge. So the sort of definition phase here, kind of where we're talking about in orchestration. Orchestration, of course, can mean lots of things, but it's really about how to manage the systems, how to manage the network, how to get things up and running. Containers are a new way, or kind of old way now at this point, of managing the applications and getting them running. So container orchestration, obviously, is the two stuck together so that we can figure out the best ways to deploy, manage, scale, container-based applications. That's what Kubernetes really is. It's container-based orchestration. By the way, Kubernetes is by design not self-monitoring. So if Kubernetes breaks, you don't know it. So that's something that's really important to keep in mind inside of here. So you can think of it this way. Application development is increasing in complexity. Deployment speed is accelerating. And at the same time, demands on quality are getting tougher. So what we used to call as good, fast, cheap is now basically quality, velocity, and sophistication. Same triad, and the intersection of all three is where unicorns go to play. So it simply doesn't exist. But if you will, the initial stair step of this server to app to log doesn't exist anymore. You've got some interesting questions inside of here. We now have an app that writes a log that lives somewhere on some server for some length of time. We actually don't know any of those things when we start off. You tell Kubernetes to give you 5 running copies, Kubernetes gives you 5 running copies. And if you ask it, it'll tell you some archaic and obsolete string of letters about 24 characters long about where it put it. So now we are dependent on figuring out where things live inside of that. That means a couple of interesting questions, things you worry about on a regular basis, but what could go wrong? If it went wrong, would I know it went wrong? How fast can I get to the what the moment, and then could I fix it? All those things become really important inside of here. So we have more simple parts and more complexity inside of this new orchestrated environment. So what does that mean? Well, basically it means that monitoring needs to change. Monitoring concepts are kind of an interesting thing. Just like containers have changed the way we deal with application space, so that we don't necessarily have machines, we now have virtual machines. We have containers that can be placed inside these virtual machines inside of here. Kubernetes has changed the way we deal with containers. The nice side is that if you monitor Kubernetes correctly, all the layers of abstraction that Kubernetes gets you between the cluster, the nodes, the pods, the containers, and the apps, give you these nice layers of abstraction so you can actually start figuring out what strata you're in and where things actually evolve. The bad side is that Kubernetes is, by default, very cryptic. And therefore, this thing called labels are your friends. You need to be able to figure out how to label things in a consistent and logical manner so that when you do look at the data that comes back from here, the monitoring application spaces and so forth, it makes some sense. And by the way, hopefully it makes sense to everybody else who's looking at it as well. Labels are definitely your friend in this space. So what about this Kubernetes thing? Well, in 1987, a computer scientist named Leslie Lamport actually has one of my very favorite quotes. And he said, "A distributed system is one in which the failure of a computer you didn't even know existed can render your own computer unusable." Never has that been truer inside of here. Monitoring these distributed systems is not like monitoring old client-server architectures. We've got all these differences that have happened. And unfortunately, we learn these through after-action reports or by history. Humans are incredibly bad at learning from history. Usually it takes us 4 or 5 times before we learn from history, and we forget history faster than we ever learn it at the same point in time. So anyway, I want to start you with one simple global rule, and we'll go into some more details around this, but make the consideration, the QA, and the deployment of monitoring a design and develop decision during the development cycle. Monitoring should not be added on after the fact. Think about it when you're building it. Monitor every layer explicitly. So by that, and by the way, there are dozens. This is not an exhaustive list here, but you can monitor the Kubernetes control plane. You can monitor the control manager. You can monitor the state metrics. You can monitor kubelets. Kubelets are your friend. If you're not familiar with kubelets, go figure out what you can do with kubelets, because kubelets are the coolest thing in this entire environment. They got more information than you can believe possible. It's really cool stuff. You can then monitor the containers. Remember, Kubernetes cluster, to nodes, to pods, to containers. And then inside the containers, of course, you have to monitor your apps as well that are inside of here. All of these things produce logs. The logs can vary in places, so they can be written to standard out. They can be written to file someplace. They can live in lots of different places. But nonetheless, you need to make sure that you're looking at some level of all these different pieces and at every level of abstraction at the same point in time. By the way, this will lead me to global rule number 2 inside of here. Make sure that your monitoring and logging happen outside of your Kubernetes cluster, okay? It's real easy to stick it in and leave it all inside the cluster. But what happens if the cluster dies? Remember, most of this stuff doesn't actually exist. And therefore, you can't get to the stuff that'll tell you what went wrong at the same point in time. Therefore, make sure that your clustering, your monitoring, and your logging are separate. If you can't see it after the fact, it didn't exist in the first place. Monitor the entire environment. I know this sounds like really sensible pieces here, but centralize your data, centralize your logs, and centralize your metrics. Your environment is still distributed, it's all over the place, and this will at least give you a fighting chance to have some clue as to what went wrong where. In a microservices-based environment, your service, which is dependent on other services, may be working fine and yet report the failure. Unless you know the interconnections as well for the entire environment, you're going to get lost inside of that headache. Remember to monitor the monitoring as well. If your monitor's not working, you might as well not have one once again. I love this tool. By the way, if you want to buy it, it's currently up on Amazon for about $3,500. So it's kind of cool. But Steve, the guy who founded Scalyr, worked for a large company and was responsible for having his application run on about 2,000 servers. He had 17 discrete tools to do that with. The problem with 17 discrete tools is they're 17 discrete tools, and they have no knowledge of what's going on between all of those different pieces. In a distributed environment on scale, more tools make things worse. You want tools to have the minimum set. So think about your workflow and think about what you need to monitor. In this dev to ops mindset, it usually goes with a workflow that says alert to metrics, dashboards, to logs, to stack trace, to source. And somewhere in the middle of that is a distributed tracing model to show you how things are performing in terms of speed. And if you look at it from that viewpoint, you really don't need 17 tools to deal with this. You need a nice set of tools. What you would also like to have is those tools have the sensibility to be able to hand data that says, oh, look, I found this, and put it in here, and say, oh, you're looking at this time slot, and put it in here, and goes, oh, you're looking at this source file. So all those different pieces become part of this. This, again, gives you another chance of making things happen. At the same point in time, particularly in the microservices space, we have multiple teams that may not ever communicate with each other. My job is to build this piece. And therefore, we have to have collaboration tools. So it's nice if those tools have the ability to capture the snapshot, the forensic work you've done, and hand it to the next team and say, something weird is going on here, could you take a look at this for me? Rather than simply saying, something's weird, go figure out what it is. Again, our response times to get things back up and running has shrunk. And we've got to be able to be as responsive as possible while we're dealing with this. This one's also a no-brainer. Data consistency. All of your tools need to have equivalent data. If you're recording one thing in microseconds, record them all in microseconds. If you're doing it in seconds, do them all in seconds. In the world of monitoring, in the world of logging, basically the timestamp is your closest friend. And you need to make sure that it's consistent. If your data is not consistent, you can't compare it. If your data is not consistent from a monitoring viewpoint, you can't use something humans are really good at, pattern matching, because you're not being able to compare the two pieces across all those things. So use consistency across this to make sure that you're dealing with this. Likewise, use the same consistency across all layers of abstraction. So save the same sets of data that you're working on across all of those pieces. One of the harder things to think about here is called ephemeral, particularly ephemeral containers. Things start and stop all the time. And therefore, if something starts and stops, did you get the data? And now ingest speed becomes an important characteristic. How fast your alerts respond. So if it takes you 5 minutes to get an alert for a container that went up and down in 30 seconds, again, it's not worth much. Your speed actually matters. Responsiveness matters. All those different things inside of here. It's the things you don't see that will get you. So, and unfortunately, even if we don't see them, they do exist out there. Especially in an orchestrated environment, you will see things come up and down all the time if you're watching closely. And if you're tracing them closely, you're going to get a bunch of worms. I actually usually call them malaria germs. They look like they're crawling all over the screen. But because, once again, we're looking at this label environment, we can group things together, and we can look at just the label of common elements across the abstraction pieces to make sense about the entire environment. And that'll help us as we go from wide to deep investigation and figure out what the heck is going wrong. Monitor without touching the app. Usually you hear this called daemon set or sidecar in this model. And you can do this. These are a couple of open source tools. FluentD, which is Cloud Native Compute Foundation, Prometheus monitoring. My product, Scalyr, is also built in the same model. But you don't want to touch your app. You basically would like to be able to monitor in ways that come across this. Similarly, think about this in terms of this. I've got all these little segments over here. I've got lag and latency. And now I've got to worry about how long things are taking and connecting them together. And there you've got a couple of other tools, open tracing and open senses, that again are your aids inside of doing this to determine how long things are taking. E-commerce space. If you take 5 seconds to respond, it's a lost sale. If you take 10 seconds to respond, it's a customer who will go complain to their friends about you. So find out where things are going and use that as part of monitoring in the distributed tracing environments. Some just common things. Be clear as crystal. If you are responsible for maintaining the microservices infrastructure, no matter what, it will be believed that you are responsible for the data that is being transmitted around. And you may not have any responsibility for doing that. Expect that to happen. As people leave companies, it will happen that people forget who is responsible for those data. So make sure that you are clear about what is being monitored and why it's being monitored across it. Keep things as small as possible. Notice that this does not say as small as capable. So make sure that your services, as well as your monitoring, are the minimum for getting what you need. Don't make it smaller just because you can inside of that. And I mentioned this before, but always keep your eye on what's going on the orchestration piece. And if you can, avoid orchestrating what you don't need to orchestrate, because all that does is add a layer of complexity to your overall environment. So modern architecture trends have changed the way that we have to look at monitoring across what we need from our observability tools. This, in turn, has changed the way that we have built tools. And we've got another layer of abstraction coming out called function as a service, Lambda, which is going to be another level of abstraction that we're going to have to monitor and maintain as well. If you want to ask questions, I'm about out of time here, but if you want to ask me questions, I'll be in the Scalyr booth, 1014. I'll show you a demo of what a Kubernetes environment looks like, and I'd love to get your feedback because this is a new world for all of us. So keep us in track, enjoy the rest of the show, and thank you for listening to me today.